evaluate the determinant of a 3x3 matrices, the first thing is you will see they put the two vertical bar instead of the bracket. So when you see this notation, that means you need to find the determinant. Now with a 3x3 determinant, you can use any row you want to, and normally we take the row 1. We use the 3 element on the row in the row 1 to use that as a cofactor, using the same strategy like cofactor, but we multiply the cofactor with this 3 number. So the way we set up to finding the determinant with a 3x3 is we take the first entry on the row 1, which is -2. Now we just draw the vertical line and the horizontal line that intersect at -2. Then the remaining 4 number or the remaining 4 element will turn to the cofactor of the first determinant form or expanding form. So you will have the -5, 2, and the -4. The next term, we put the negative sign into it because when you're finding the determinant of a 2x2, there's a sign sequence order. You have to follow it. 2x2, they come with a positive, negative, negative, positive. When you have a 3x3, finding the 3x3 determinant, we start from positive, negative, positive, negative, positive, negative, positive, negative, positive. So if you take the row 1 as a cofactor form to finding the determinant, the first term we keep the positive, but this example, just because the -2 is a negative value, if this is a positive number, then we just keep the positive value. The following term, we should fill in the negative sign, and that's the reason why I put a negative sign here. Alright, now the following term, the number is 3, and then I create a 2x2 matrix. The 2x2 determinant form. So I draw the vertical line, and this horizontal line intersect with 3. Let me erase the first line here. Alright. So now I have the horizontal line and vertical line intersect at 3, and we take this 4. The remaining 4 is outside of the line. That would be the cofactor with the second term. So we have the -5, 2, 0, and a -4. Now the last term is a positive. So I write down the positive sign. And now we move on to taking the last term, the last number on the row 1, which is -2. So I draw the vertical line and the horizontal line that intersect at -2. So this is a -2. I use a parenthesis to run it. Now we create a 2x2 determinant form. So we take this 4 because this 4 is outside of the line. So I have the -5, -5, 0, and a 2. Now we start to solve the determinant, which means cofactor here. Finding the cofactor of this determinant form. And we always go with the negative diagonal direction first to multiply the negative diagonal direction to number. So when you have the -5 multiply -4, you will get a +20 minus 2 multiplied by 2, which is 4. Then you have the -2 stay in the front, minus 3 times these two, you get a 20 minus 0. The next term, because it's double sign here, so when I convert these two signs, it turns to a negative value. So I put a 2 here. Now multiply these two, you get a negative 10 minus 0. Because 0 multiply any number stays 0. Now we clean up. Subtract these two, you get a 16 minus 3 multiplied 20 minus 2 multiplied by negative 10. Then you have negative 32 minus 60 plus 20, which is negative 72. Negative 72 represent the determinant value of this 3 by 3 matrix. This number indicate, yes, there's an inverse. There's an inverse of this 3 by 3 matrix. So keep in mind, when you finding the 3 by 3 determinant by hand, you can take the second row. That is correct. That is okay to solve it. You can take the third row. That is okay. And I just used to you take the first row, and I wrote down those 3 numbers. And inside of the 2 vertical bar here, that represent the cofactor when you have the element is negative 2. And you just use the regular way to find the determinant. Start with a negative diagonal direction to subtract the positive diagonal direction. And narrow down until you get a single value. When you have the final result is a number, it could be positive, it could be negative. It doesn't matter. When you have the number occurred by the end, that means the 3 by 3 square matrix has an inverse. If the outcome turns to a 0, that means there's no inverse of the square matrix.